Mm-hmm.
All right, so today we're talking about evaluating and analyzing functions. Okay, that's going to be page 7 and page 8 in your table of contents. Okay, so by the end of the lesson today, you'll be able to evaluate and analyze different types of functions. Now, you all have been dealing with evaluate in your younger years. What does evaluate mean? Solve. So that's exactly what we're going to do. We're going to be given a function, okay, in this case, g of x equals x squared plus 8x minus 24, and we're asked to find each function value. So for this very first one, g of 6, that literally means that 6 is going to replace x in the function. So this is going to become 6 squared plus 8 times 6 minus 24. And then we just, square, multiply, add, and subtract. All right? What's 6 squared? Anybody? 36. And what's 8 times 6? And then we're going to work this out. 36 plus 48 minus 24. 60. And there it is. We have evaluated the function g when x is 6. Simple as that. Okay? That is about as simple as they come when it's just a number. They can get a little tricky when you start plugging in, like expressions like we have in B and also in C. But the same rule still applies. We're going to replace every x with a negative 4x. And it's also important that you include your parentheses. Okay? I should have done that back here. I should have put 6 inside of the parentheses. I'm going to do that real quick. So I'm going to plug it in. Negative 4x, that whole thing is getting squared. Plus 8 times the negative 4x minus 24. Is everybody seeing how I'm plugging it in? And you want to be very careful, especially when you're plugging in expressions like a negative 4x. Because that very first thing is you're going to square it. What do you get when you square a negative 4? You get a positive 16, okay? Now let's just say you didn't put the parenthesis in and you just put the square. You might forget automatically to even square the 4, let alone a negative 4. You know what I mean? You just might say it's just negative 4x squared, but it's not, okay? It's negative 4x times negative 4x, which is 16. What's x times x? X squared. What's 8 times a negative 4x? Negative 32x. And then we have a minus 24. Now, unlike A, we don't have numbers here. Okay, so we just can't, add everything together, subtract everything, and get one solid number. So when we have something like this, we definitely want to make sure we combine any like terms. Do we have any like terms? No, we got x squared, we got an x, and we just got a regular number. So that is it. It just asks you to find the value. That's a very good question. Some students like to go that next step and factor it. You don't have to do that, okay? So just by simply evaluating, you're just going to plug in the value and then combine like terms where you need to, but you don't have to go that next step to factor it or anything like that. No, it would not.
No, like when I see that, it's just like a force of habit there.
No, that's totally fine. Now I just hope that you do it correctly. Right. Okay, so if you do go that next step, you better make sure it's correct, or else we're going to, circle and then. This one, same thing. We're going to plug in 5x plus 4 into x. I'm going to include my parentheses. And now, let's see who's going to get the 5x squared plus 4, or 5x plus 4 squared. I heard on this side. You FOIL.
Oh, yeah.
5x plus 4 squared is the same thing as saying 5x plus 4 times 5x plus 4 is 2 of them. So you got to FOIL it. 5x times 5x. 25x squared. Outer, 5x times 4. 16. Okay, don't let that throw you off. Make sure you FOIL that. Anytime you have this is known as a binomial, when you have two terms. When you square it, you're actually going to FOIL. Over here, what are you going to do to the 8? Distribute. 8 times 5x. 40x. 8 times 4. 32. Minus 24. Can I combine any like terms? The 20x's and the 40x. So I can combine these. And what is that? What's 20x plus 20x plus 40x? 80x. 32 minus 24. Can I combine anything else with that? The 16. What is that? 24? What happens to that 25x squared? Can I combine that with anything? There you go. That's your answer. We're good? You guys remember doing this in the past? Okay, good. So I want you guys to try one on your own. Alright? Now, I'm noticing some of y'all came really close to that paper. Okay? So you might have to like either mentally do this or like split the page, because we do got like another example after this before we get to that part.
So we have 2 more examples?
About 3.
Oh. I have split 2, but 3 ain't gonna work.
You can do 2? Okay, so as well what you do. The second one, if you already know that you're not gonna be able to fit 3 in that space that you got, I want you to do this one.
We could do it under here and then we glue it, it's even. We go on homework.
You can do that. You can do that on the page where your homework goes for the night before. Or better yet, I want you to do number 2. I want you to do it in the pod notebook section. Okay, so flip over to your pod notebook section.
It's what we're doing right now.
If you do not have space,
What we're doing right now.
the one we're about to do, and I want you to do it right underneath today's dates pod. This is only if you don't have space. Okay? And then you can put a little note where your notes are and say C pod 824. Okay? This one, the one that you're doing, I want you guys to do this one on your own. Okay? The first one, f of 12. What'd you guys get? 27 over 121. Anybody use the calculator to see if that reduced? Yeah, but it didn't. You should convert it back to a fraction.
Yeah,
It doesn't? Okay. What about this one? I need one person to say this because it's going to have variables in it. Caleb.
12x plus 3 over 36x squared minus 12x plus 1. I don't know if I got that right.
Did you guys get this? Yeah, that's what I got too. Good stuff. Okay, now the last one. Not only do you got to distribute twice, but you got to FOIL and then combine like terms on both the top and the bottom. Michael, what you got?
Negative 6a plus 19 over 9a squared minus 42a plus 49.
Did you guys get this?
I already did that.
What do you mean?
Mine is 6A and mine is
Oh, okay. So, this is the foiling and everything math correct. That's good. Now, the one thing, you're not going to be able to reduce this negative 6a and this negative 42a because they're not alone. Technically, negative 6a is attached to a 19, and this negative 42 attached to a 49 and that. The only way that you actually cancel those is if they're being multiplied instead. Okay? That's as far as we can go. How do we do? If you didn't get them, watch your signs, okay? And I know if you were like me, like I try to cram mine in like a corner. So you know, you might need a little bit more space to try to make sure you don't miss when you symbol.
Hand it all on a sticky note.
Okay? Or on a sticky note. Alright? Now, a piecewise function, you don't have to worry about the definition, okay? That's more for me to say. But a piecewise function is a function that is defined using two or more equations for different intervals of the domain. So, like C in our problem of the day, that was an example of a piecewise function. Okay, it's basically different parts of different parts of an equation that come together to make up one. Okay, but we use this as well to evaluate functions. All right, and so here we got two pieces to the piecewise function. Make sure you get down the example. Okay, f of x equals 3x minus 5, and f of x equals x squared. Now this part, the 3x minus 5 of the piecewise function, is only defined for the x values that are greater than 4. Okay, so anything greater than 4 is on that function, the top one. But everything that's less than or equal to 4 is on the bottom function. But to evaluate these, don't worry, don't stress, it's actually pretty simple. Depending on what they're asking you to find or asking you to evaluate, you just got to make sure you're plugging it into the right part of the piecewise function. Okay? And to do that, you look at the value. F of 7. Okay? You go to this restriction part right here. Is 7 greater than 4 or is 7 less than or equal to 4? Greater than 4. So because 7 is greater than 4, you're going to plug 7 into the first part of the piecewise function. Okay? So you're going to use that first equation of 3x minus 5, and you're going to plug 7 in for x. 7 times 3 is minus 5. What is it? And that's the value of the function at 7. That's all. You just got to look at the restriction part, see where your number lies, and then plug into that piece of the piecewise function. 4, is it greater than 4 or less than or equal to 4? It's in the less than or equal to. So we're going to plug it into x squared. So it's going to be 4 squared, and what's that? 16. Will it always be the same numbers? No. It just happens to work out that way. So again, you look at the x value you have to plug in and see where it lies. Is negative 3 greater than 4 or is it less than or equal to 4? Less than or equal, so we're going to plug it into the second piece of the piecewise function. And what's negative 3 squared? And that's it. Okay? You got one that you're going to do yourself. That's what you're doing yourself. Now, one thing I don't know if I stated this, but f of x, okay, that's the same thing as y. Okay, when we're talking about functions, we're talking about things that have an x and a y. They're on x and y planes that can be graphed. You have an x value and corresponding y value. So these x's that you're plugging in to the part of the function, even if it's just one function, okay, you're finding its corresponding y. Okay, so when you're plugging in 10 for x, you're trying to figure out, okay, so x is 10, what is y? Okay, so if you were looking at a graph, you would go over to where x is 10 and then see where the graph hits 10 and where it matches up to on the y-axis, okay? So that's really what you're finding when you're plugging in these values. You're trying to figure out the corresponding y. Now 10, is 10 less than or equal to 1, in between 1 and 3, or greater than or equal to 3? So you're going to plug it into number 3, right? So you got 6 minus 2 times 10. 6 minus is, okay? Number 2, does it lie on first piece, the second piece, or the third piece? Second piece. Now, this one doesn't have an x, does it? It's just basically saying y equals 3. So no matter what x values are in between 1 and 3, the y value is always 3. So it literally is just 3. So that means if you were to look at the graph of this piecewise function, that means from 1 to 3. Actually, it's not a closer look open. It basically looks like this. That's exactly what it looks like. So 2, when x is 2, y is 3. No matter what. And 10, first piece, second piece, and third piece. First. What do those bars mean? So I have -2, absolute value of 1. What's absolute value of 1? What's -2 times 1? Questions? All right. Symmetry and even odd functions, okay? The graph of relation that is symmetric to the x-axis and or y-axis has line symmetry. And a graph of relation that is symmetric to the origin has point symmetry. So what does that mean? Garden variety version. Basically, if you were to graph an equation, a function, okay, on an x and y plane, if you could fold your paper on the y-axis and basically the right side of the graph would line up to the left side of the graph, it has line symmetry, okay? Basically, it cuts the graph in half. However, if it has origin symmetry or point symmetry, that basically means it's like you flip it over the x and you flip it over the y. All right? We're going to look at a few of them so you can kind of see what I mean by that. Algebraically, if a function is symmetric to the y-axis, they're called even functions, okay? And to determine if functions are even algebraically, you basically plug in a negative x for every x that you see. And if you simplify it and get the original function, it's even. All right? This is at the bottom of that page. You're filling in the blanks. If a function is symmetric to the origin, it means that it's odd. Algebraically, if you plug in a negative x and you get the exact opposite of your function, it's odd. So what we're going to do is we're going to take a look at a few functions, okay? You got 4 functions down there. And I actually would like everybody to grab the calculator. It's also what you guys to grab some of these as well, okay? So if you have a calculator, pull it out or go grab a room. All right, so what we're going to do is we're going to graph each one of these functions and then we're going to analyze whether it's even or odd by looking at the graph. Remember, if it's even, it's symmetric to the y-axis, meaning that if we folded it at the y-axis, the left side will lie over the right side. If it's odd, that means it has origin symmetry, meaning that if we took one section, reflected over the x, and then reflected over the y, it would match up to the other half. If it's neither y-axis or origin, then it's neither. Then we'll do it algebraically. So let's turn on our calculators. On button, bottom corner. Go up to y equals. Okay? Now, if you have things sitting in your y equals like I do, all you do is you press clear, and it gets rid of them. Go down, clear. Go down, clear. Anything that's in there, go ahead and clear it out. Now, hopefully everybody has a y equals. Does anybody not have y equals? Good stuff. So now we're going to type in the function. Y equals. Yes? Like it's not even turning on? Okay, put it on my desk and grab it. We're going to type in the function now. The function was 4x cubed plus 1, correct? So we're going to type it in. You type in 4. X is located to the right of the alpha button. So you press 4 and then you go to the right of the alpha button and you press X. Now we have to go to Q. You press this little caret, I call it a caret, some people call it up arrow, but I say caret. You press the caret button and then you type in a 3. Now if your calculator does not automatically go to the exponent, it just does like literally the caret button, then you're fine, okay? But if yours is like mine, you have to push the over arrow so that it gets out of the exponent. And then go plus 1. So does everybody's calculator look like this outside the one that has like the caret and the 3? To the right alpha. calculator before you. And I'm doing different things in other classes, and who knows, that window may be set from 0 to negative 100. We don't want that, okay? So when you're going to go graph, just as a good habit, press the zoom button. The zoom button is the third button at the very top. Okay? This gives you all these options. You can zoom in, zoom out, change decimal, go to the square window. The one we want is standard. So you just press 6. 6 takes you automatically there. You can scroll down to 6 and then press enter. But basically what it does is it takes you to a standard negative 10 to 10, negative 10 to 10 window. Does everybody's graph look like this? All right. Now, does this have y-axis symmetry? If I were to fold it at the y-axis and then kind of like, if I were to take my screen and be able to go like this, would this part lay on top of this part? No. Now, does it have origin symmetry? If a graph is go through the origin, there's no way to have origin symmetry. Okay. So, this is actually one of those neither situations, okay? So the answer for this one is neither. And I'll show you how to find it algebraically too, because sometimes you'll get a graph, you're like, oh wait, I can remember this, this one looks like it might be odd or it might be even. There is a way you can kind of confirm it algebraically. Yes?
Well, how would we do that for that?
Oh, I'll show you. I'll show you. Okay, here we go. This is how we figure it out. We're going to plug in a negative x into every x we see into the function. Okay? So we have 4 negative x cubed plus 1. Everybody see what I did there? All I did was plug in a negative x. You can do this like right off to the side of on your paper. Now, when you cube a negative x, you don't have to write this down, but I'm just doing it for visual purposes. This is what you're doing. Negative x times negative x times negative x. What's negative x times a negative x? It's a positive x what? Squared. What is an x squared times a negative x? Negative x cubed. Okay? So this basically turns into 4 times a negative x cubed plus 1. This will be written like this, negative 4x cubed. Okay, please don't write 4 negative x cubed. Okay, the negative will go in front of the number. Plus 1. Without a calculator, this is how you figure out if a function is even or odd. Is this the exact same thing as the original problem? No. If it's not the exact same, it's not even. It has to be the exact same thing. So it has to be a positive 4x cubed and it has to be a positive 1. But it's not. In order for it to be odd, you basically have to have the opposite sign of every term. We have it here with 4x cubed and negative 4x cubed. That's the opposite, but is the 1 the opposite? So this is neither even nor odd. It has to be the exact opposite in order for it to be odd. That's how you do it without a calculator. But not only that, since it didn't go through the origin, there's no way we could have reflected anything in the same sense. Let's look at the next one. Okay? We're going to graph it first to get some practice with the calculator. What do I go to type this function in? Y equals top left. How do I get rid of all this writing? Clear. I have to type in x to the 4th. Where's x? Next to the alpha. And how do I get the 4th power? Caret button and forward. I do too when I didn't have my braces. Okay? But I get them off tomorrow. I'm so excited. Okay, sorry. Focus. So, how do I get my cursor out of the exponent? I press the over button. Do you have to worry worry about it if you got the actual caret symbol in there. No. What's the next part? I forgot. Minus 10x squared. Minus 10x. Where's x? Side the alpha. And then squared. You want a shortcut for squared? That button right there that says x squared. If you forget where it is, you can just do caret and then 2. And then what's the last part? Plus 9? Alright. Now I've already adjusted my window back to the negative 10 to 10, so I don't have to go back and do some 6 again. Because I know I'm dealing with this calculator now. I've done adjusted. So I can just press graph. And everybody's graph should look like a W.
What?
Okay? If yours does not look like a W, we got some issues. Okay? We good? Now, does this look like it is symmetric to the y-axis? It looks like it's, is it even or odd if it's symmetric to the y-axis? Even. Okay? But we can test this algebraically by plugging in what? Negative x. So every x we see, we're going to plug in a negative x. Question, go ahead.
Okay. So say, like, if the exponent is an even number, wouldn't it just keep it the same?
It would keep it the same, yeah. Would it keep the entire function the same? It depends on which other terms are. The ones that don't have x's. Okay? So when you raise a negative x to a even power, what happens? It turns positive, and it's going to be a positive x to the what? 4. What about here? Negative x squared, what is that? Positive what? Now that 10 does not change to a positive, it still stays a negative 10 because all we did was square the negative x. And we bring down the 9. Isn't this the exact same as the original problem? That's why it's even. I want you guys to give C a whirl on your own. You guys give for C. What was it? It was what? It was even. Algebraically, if I plug in a negative x and raise it to the 4th power, it turns into a what? Exact same thing, making it even. Down here was this, you know it was odd, right? A negative x cubed minus 6 times the negative x. What's negative x cubed? And what's a negative 6 times a negative x? A positive 6. And you see how it's the exact opposite from the original problem? Every term is the exact opposite. Okay? That's how you show that algebraically.